Hello everyone and welcome back to the channel. Today we have a very common but trusting a problem on our common workbench. This is a standard 30-50 watt electric kettle that has completely stopped working. Most of the people would just throw this away and buy a new one. But as you know, here at Solder and Solve we believe in fixing things. Not only does it save money, but it also better for the environment. In this video I am going to show you how to diagnose, disassemble and perform a professional grade repair on this unit. Let's get started. The first step in any repair is understanding the why. Why did it stop working? Before we look at this electronics, we need to get inside. I am starting by removing screw from the bottom plate using Phillips head screwdriver. Notice how I am keeping screw organized, and this is a tip you should always follow. We can see the internal layout. But to really see what's going on, I also need to remove handle assembly. This part can be tricky because of hidden clips. So take your time and don't force it. Now we have a clear view of the wiring and main power switch. Now let's bring in the multimeter. This is the most important tool for any electronic devices. I am setting it to continuity mode. First I will check the heating coil. The coil is surrounded by white ceramic paste which help to heat dissipation. As I touch the probes to the terminal, look at that, we are getting the reading 37.2 ohm. This is great news. It means the heating element itself is perfectly fine and hasn't burned out. However, while inspecting the base, I notice a lot of corrosion and rust. It looked like water has been leaking from the tank into the electric component, which likely caused a short circuit. To fix a leak, you can just slap on the slum glue and hope for the best. You need a clean surface. I am using a small brush and some cleaning solution to screw away all of the rust and calcium buildup. I am spending a good few minutes to sanding this area down to bare metal. This ensures that our sealant will bond permanently. If you skip this step, the repair will fail within a week. For the repair, I am using a specialized 2-part heat-resistant epoxy. This is crucial because standard glue will not melt or release toxic fumes when it kettle boils. I am mixing the equal parts of the resin and the hardener. You want to stir it until the color is completely uniform. Now I am applying this thick even layer over the pinhole and around the entire base stem where the heating element meets the chassis. The epoxy designed to withstand temperature while above 100 degrees Celsius. Once applied, we need to let it cure. While the package says it dries fast for high pressure environment like kettle, I recommended letting it sit for 6 to 7 hours to achieve the maximum strength. See, this is a tiny pinhole right at the bottom edge. That's our culprit. We have waited for the curing process and now it's time for the moment of truth. I am reassembled the handle and secured the base screws and double checked all the wiring connection. Let's fill with water just up to minimum mark for this test. Power on. Within a few minutes, listen to that sound. The water is reaching a rolling boil, and most importantly, the bottom is bone dry. No leaks, no short. We have successfully saved this kettle from the landfill. If you enjoy this deep dive repair, give a video a thumbs up. It's really helped to the channel, and leave a comment if you have any question about the proxy I used. As always, don't forget to subscribe for more solder and solving. I am here for you. I will see you in the next one. Bye bye.